Let's talk about exponents. Let's first see what an exponential expression should look like, and the parts of it. So, in this example, 5 to the third power, the whole expression is an exponential expression, and the 3 is the exponent, where the 5 is the base. So as an example, 125 equals to 5 to the third power, which means that 5 to the third power is the exponential form of the number 125. So 5 to the third means 5 times 5 times 5. So the exponent means how many times the base is multiplies itself. So there are some rules about how to work with exponents. The first one is multiplying powers. If you are multiplying powers with the same base, keep the base and add the exponents. So the rule would be x to the m times x to the n equals x to the m plus n. Or, as in this example, 2 to the 6th power times 2 to the 3rd power is 2 to the 6 plus 3. In other words, 2 to the 9th power, which equal to 512. So yep, when you multiply powers, you add the exponents. Dividing powers. When dividing the powers with the same base, keep the base and subtract the exponents. So the rule will be like x to the m over x to the n equals x to the m minus m. Or a numerical example, 2 to the 6th power divided by 2 to the 2nd power equals to 2 to the 6th minus 2, 2 to the 4th power, which equals to 16. So when you are dividing powers, you need to subtract the exponents. All right, let's do some examples on exponents. So let's start with the basic rules that we first learned, multiplying and dividing exponents. Okay, so for example, 3 to the 2nd power times 3 to the 3rd power would be 3, 2 plus 3. Because I'm multiplying, I add 3 to the 5th power, which would be 3 to the 4th is 81, and 5th would be 243. So let's do another example. What if I have some variables? 2 s to the 2nd power times 4 s to the 7th power. I have to do regular multiplication with the numbers. So 2 times 4 is 8. Then I have s to the 2nd and s to the 7th power, which is going to be 2 plus 7. In other words, 8 to the s to the 9th power. Let's do another one. S to the 2nd power times t to the 4th power times s to the 7th power and t to the 3rd power. Like terms. The bases are the same, s to the 2nd and s to the 7th, which is going to be s to the 9th. And I have t to the 4th and t to the 3rd, which is going to be t. 4 plus 3 is 7. So, check out these examples. And let's do more examples on dividing. exponents. When you are dividing exponents, you subtract. When you are dividing exponential expressions with the same base, you subtract the exponents. So let's do an example of it. Let's use black this time. So, dividing. Let's start with the basic one. S to the 12th over S to the 4th. So my answer is going to be S 12 minus 4, which is S to the 8th power. What if I had multiple variables? S to the 12th power, T to the 8th, over S to the 4th, and T to the 3rd. S's and T's. So S to the 12th over S to the 4th is going to be S to the 12th minus 4, while the T, 8 minus 3, which will end up being S to the 8th power times T to the 5th power. What if I have numbers, variables all together? What should I do? Here's an example for that. 36, A to the 5th, B to the 8th, over 4, A to the 2nd, B to the 3rd. This is a regular division. 36 divided by 4 is 9. I wouldn't, if this would be a whole number division, you would simplify that as a fraction. Okay? So, 9. So let's see what's left. I have A to the 5th, I have A to the 2nd. Let's write this over here, because 9 is going to be on top, and 1 is going to be on the bottom from this division. A to the 5th, A to the 2nd, there is A to the 3rd left on top. There is more on top. B to the 8th over B to the 3rd, there's going to be 5 of them. I don't need to write this one, so my final answer would be 9, A to the 3rd, and B to the 5th. Hope that's going good. Let's do some more examples. The example is going to be getting more advanced and advanced as we go. So the next rule is power of a power. If you are raising a power to an exponent, you multiply the exponents. So x to the m in parentheses over to the n power equals x to the m times n. In these cases, you will see parentheses. So a quick example, 5 to the 3rd power in parentheses to the 2nd power equals 5 to the 3 times 2, in other words, 5 to the 6th power. Next rule is power of a product. So when there is multiple terms inside the parentheses, the exponent is multiplied by each term's exponent. So let's look at the rule. So I have x times y in the parentheses, and they both go to the nth power. So if I simplify this, it will be x to the n power times y to the n power. And as an expression, again, a times b in the parentheses squared would be equal to a squared times b squared. So when you take a power of a product, you apply the exponent to all the terms of the parentheses. So power of power. Let's write up an example for this. 3 to the 2nd power to the 5th. Well, there is always going to be parentheses in this type of questions. Power for power, the rule says multiply the exponents. 3 to the 2 times 5, which is 3 to the 10th power. At this point, I'm going to ask Siri what 3 to the 10th power is. Hey Siri, what is 3 to the 10th power?
3 raised to the 10th power is 59,049.
59,049. So, there you go. There was nothing wrong with using Siri when you need it. Utilize the technology. Let's do another example. What if I have multiple terms in this parentheses? 2a, and the a actually has an exponent, and this whole thing is to the 3rd power. Now, pay attention. This exponent 3 will be distributed both to this and to this term. So, I will have 2 to the 3rd power, then I will have a to the 2 times 3. Because this 2 has actually a 1. We don't write the exponent 1. So 1 times 3 is 3, and 2 times 3 is 6. So my answer is going to be 2 to the 3rd power is 8, and 8 to the 2 times 3 is 6. What if I have a negative number? Negative 3 times a to the 3rd to the power of 3. Well, be careful. The exponent is an odd number. If I'm multiplying negative 3 by itself 3 times, I will end up with a negative value because the exponent is an odd number. If this would be an even number, you would end up with a positive number. 3 times negative 3 will give me a positive 9, but then times a negative 3 will give me a negative 27. So if I had the even number, I would be multiplying it one more time with a negative, which would turn to a positive, but not in this case. So negative 3 to the 3rd power is negative 27, and a to the 3rd power is a to the 3 times 3, 9. Our next exponent rule is the quotient law. If the quotient of the bases is powered by the same exponent, then the result is both numerator and the denominator, each powered by the given exponent. That is a lot of words, right? So let's look at the example. If I have a division inside the parentheses, x over y, and they all go to the n, I distribute that exponent to every part of that division. So quotient means division, okay? X to the n over y to the n. So a number example would be, for example, 2 over 3 all to the 4th power, 2 to the 4th power over 3 to the 4th power, which 2 to the 4th equals to 16, and 3 to the 4th power equals to 81. So the answer would be 16 over 81. So when you take a power of a quotient, you apply the exponent to all parts of the quotient. One of the most important and confused rules. So pay attention to this one extra. Negative law, negative exponent law. If the base is powered by a negative exponent, then the base becomes the reciprocal with the positive exponent. So what is a reciprocal? Remember, we flip the fraction. We put it over 1 if it's a whole number, and we flip it, and we turn the exponent to positive. So x to the negative n power would equal to 1 over x to the positive n. And a number example would be something like this. 5 to the negative 3 power would be 1 over 5 to the positive 3, which would be 1 over 125. And vice versa. If your negative exponent is in the denominator, flip it and bring it to the numerator and make it positive. So 3 to the 1 over 3 to the negative 2 power will equal to 3 to the positive 2 power, which equals to 9. So when you have a negative exponent, you switch the base to its reciprocal with a positive exponent. If the base has the negative exponent in the denominator, it moves to the numerator to lose its negative sign. Our next rule is zero law of exponents. So this is pretty straightforward and basic, guys. Any base powered by zero exponent equals to 1. So x to the 0 equals 1. Any number, any value, as long as they have a zero exponent, they equal to 1. 5 to the 0, a to the 0, or 5 times a, all in parentheses to the 0 power, all equals to 1. So any number to the 0 power equals 1. So let's write an example. Mixed examples. There we go. Mixed examples. What if I have positive and negative exponents? Y to the second power times y to the negative 4. This is just a regular multiplication, so the rule says add the exponents. So if you add 2 to the negative 4, 2 plus negative 4, you will end up with y to the negative 2 power. And the negative exponent rule tells me flip this over, because this, I can write it like this too, y to the negative 2 over 1. Flip it, take the reciprocal, and make the exponent positive. Let's do a little bit more complicated example. More numbers. The moment you see parentheses, think about power of a power rule. So, and y to the third over to the negative 4 power. The first thing you should be doing is simplifying this. So the first thing to simplify is distribute this exponent to all terms in your parentheses. 3 to the negative 4 power. X to the negative 2 times negative 4, going to give me x to the positive 8 power. Negative 2 times negative 4 is a positive. And y to the third to the negative 4 power will give me y to the negative 12. I have negative exponents that I need to deal with. This whole thing is over 1. So flipping it will make these 3 to the negative 4 and y to the negative 12 powers positive. So x to the 8 stays where it is. 3 to the 4th comes as positive, and y to the 12 becomes also, negative 12 also becomes positive. Therefore, my answer, final answer would be x to the 8th over 3 to the 4th is 81, and y to the 12th. Any number. The next one is, I'm going to talk about 0, so I feel like sometimes people get confused on this one. Any number, guys, any number. To the 0 power equals 1. But the problem is this. Sometimes this is the mistake I see. So I'm going to show an example about that in a particular mistake. I'm going to erase this board quick, and we'll start again. The biggest mistake I see on this one is something like this. let's say I have a to the 5th, b to the 0, c to the 2nd, type of, and then let's say I have to the 2nd power. This term is already 1. Only that term is 1. So don't confuse it, because sometimes I see mistakes like when the moment people sees a 0 exponent, and doesn't matter what the base is, they assume everything is 1. The exponent only affects the base it's on. So in this case, the answer would be A, 5 times 2 is 10, and C, 2 times 2 is 4. B to the 1 to the 2nd power is still going to be 1. Okay? Let's do one last example and finalize this video over here. "36 a to the 5th over 4 a to the 4th and b to the 5th, all to the negative 2 power." Now, we're talking about reciprocal, we're talking about flipping. This is still a fraction form. So because I have this negative 2 exponent, I can just flip this, make the numerator the denominator and the denominator the numerator, and turn this exponent to positive. So how will that happen? 4 a to the 4th, b to the 5th over 36 a to the 5th to the positive 2 power. Positive 2 power. First, simplify inside the parentheses as much as you can. So let's start what we can do. 4 and 36, I can simplify them by 4, and I'm going to end up with a 9. So I have a 9 here. I have a to the 4th on top, and I have a to the 5th on the numerator on the bottom. So when I simplify these, there's 4 over here and there's 5 over here, only one's going to be left on the numerator. And there is no like term that can go with the b to the 5th power, which is going to be going to the numerator and still to the positive 2 power. Now I'm going to use the power of a power and the quotient rules and distribute the exponent to both terms. B to the 5th to the 2nd power will be b 5 times 2, 10, over 9 squared is 81, and a squared. So your final answer will be this. Hope that was helpful. Let me know if you guys have any questions.